What's up, my first class Falcons? This is Miss Pearl coming at you from my dining room. All right, and we are going to go over section 7.7, simulating compound events. So let's read the key concept here. A simulation is a model of a real-world situation that can be used to predict results or outcomes when the actual event is difficult to perform or record. So let's say you wanted to predict something that's going to happen. Let's say, is it going to be rainy or sunny? You can maybe assign 10 numbers to represent if it's going to be rainy or sunny. Maybe you're going to say, okay, 0 through 3 represents, oh, it'll be sunny out. And then 4 through 9 represents it's going to be rainy out. All right, a simulation uses a tool such as a spinner, number cube, coin, or random number generator. So most of these questions, they're using a random number generator for which outcomes have the same probabilities as the actual event. So again, using a simulation is to help you predict something that's going to happen. And this section, we're talking about compound events. So they're talking about something happening more than once in a row. At a startup company, there is a 40% chance an item is defective. The random numbers below represent 10 trials for simulation. Design a simulation to estimate the probability that the next 2 items that are checked are defective. Again, defective means that it does not work. Use this simulation to estimate the probability. Use pencil and paper. Explain when it would be appropriate to use a simulation to find the probability of a compound event. So let's look at our first question. Which of the following assigned numbers for defective and not defective items can be used for the simulation model? So we're going to look up here. We have a 40% chance that it is defective. So remember, 40% means 40 out of 100, which is the same as 4 out of 10. So we want 4 out of the 10 numbers to represent defective. So if we look at A, and they want to assign defective 0 through 4. So if we look, that's actually 1, 2, 3, 4. That's actually 5 numbers that represent defective. So that's actually not correct. They're trying to trick you a little bit. If we look at B, defective 0 through 3, that could work, but not defective 4 through 10. So our numbers are actually only going 0 through 9. They're not including 10. All right, and then if we look at C, if they want to assign defective 0 through 5, that's going to be way too many numbers. Now for D, they want to assign defective 0 through 3. Okay, so that works. That means that we have 1, 2, 3, 4 numbers, 40%. And then not defective is 4, 5, 6, 7, 8, 9. That is 6 numbers. So that would be 60%. So our answer is D. The experimental probability that the next 2 items are defective is, so we're going to look up here, and we want to look and see when both numbers are 0, 1, 2, or 3. So 5, 0, that's not going to count. 1, 3, yes, because both numbers are less than 3. 1, 1, that's it. 1, 5, nope. 9, 4, nope. 6, 7, nope. 4, 9, no. 5, 1, no. 6, 6, no. And then 1, 4, no. So that's 2 out of 10. Again, both numbers needed to be defective, which means they had to be 0, 1, 2, or 3. And 2/10 equals 20%. Put that in, and let's check our answer. Fantastic. You use a number cube to simulate an outcome that has 1/6 probability of occurring. The number 1 represents the desired outcome. The numbers 2, 3, 4, 5, and 6 represent other outcomes. You want to simulate 10 outcomes. How can you find a list of random numbers that represents the desired outcome occurring exactly 3 times in the simulated 10 outcomes and the 10 simulated outcomes. Find a list of random numbers that simulates the desired outcome occurring exactly 3 times. How can you find a list that represents the outcome occurring exactly 3 times? So let's remember what is important here. The number 1 represents the desired outcome, and then we want the desired outcome 3 times out of the 10 simulated outcomes. So let's look at our options. First of all, I'm going to look at B and D, and I'm going to say that they can't be used at all. And I'm not even going to really go through it. Why not? Because they're saying find a list of 3. Well, that's not going to work. We want to find a list of 10. We know this because we have 10 simulated outcomes. So let's look at A. Find a list of 10. Yes, we want that. Of the assigned numbers with 3 numbers that are 1. Do we want that? Yes, we do. We want 3 numbers that are 1 because that's our desired outcome. Let's double check C. Let's find a list of 10 of the assigned numbers with 3 numbers that are 2, 3, 4, 5, or 6. Okay, we do not want that, right? Because that's not our desired outcome. Which of these lists simulates the desired outcome occurring exactly 3 times? So we want to find one where the number 1 occurs 3 times. So let's look at A. How many times does the number 1 occur? Only once, right? Can't be A. How about B? 1, 2, 3. Okay, we're looking good. I'm pretty sure it's B, but I always want to double check. Let's look at C. Just twice. And then D 4 times. Okay, so we want the one where the number 1 appears 3 times. This is the last question I'm going to do with you guys. About 40% of the people in a state work for a small business. Use a simulation to estimate the probability that at least one of the next 4 people work for a small business. What action should be taken to simulate the event? Design the simulation and estimate the probability. All right, now we're in our question. Which of the following is the correct action to simulate the event? Again, I always like to look back in the question. So we want to know the probability that at least one of the next 4 people work for a small business. So let's look at our answer options. 4 people are tested at random to see if they work for a small business. Yes, that's going to be our answer because they're asking, they want to know what's the probability of 1 out of 4. So it doesn't make sense to only ask 1, 3, or 2 people. Which of the following assigned numbers for people who work for a small business and those who don't can be used for the simulation model? So again, we're looking at 40%. So that means 4 out of 10 work for a small business. So we want to look at these answer options and decide which one of them means that 4 out of 10 work for a small business. So that means 6 out of the 10 don't work for a small business. So A is trying to trick you because 0 through 4 is actually 5 numbers. Okay, so it can't be A. Let's look at B. Work for a small business 0 to 3. So that's 0, 1, 2, and 3. That's good. But now don't work for a small business 4 to 10. That doesn't work because we're not including 10. So it can't be B either. C, work for a small business 0 to 3. Yes, we want that. We want that. And then don't work for a small business 4 to 9. Yes, that is our answer. Now they're asking the experimental probability that at least one of the next 4 people work for a small business is what percent. So we're going to go back up here and we are going to look and see how many of these have at least one person who works for a small business. So we're looking to see if at least one person is numbered 0 through 3. All right, so is there at least one person 0 through 3 in here? Yes. in here? Yep. Again, I'm looking for numbers 0, 1, 2, or 3, and I need at least 1 in there, right? Okay, so this last one, no one is between 0 and 3. This works. This one works. This one works. And this one. All right, again, I'm looking number at least one person, numbers 0 through 3. At least. Now, be careful. If on your question, it might say exactly 1 or exactly 2, exactly 3. Right, this one counts. A lot of these are fitting the bill. So 19 out of 20 have at least one person who worked for a small business, which equals 95%. I hope this helped. If you have any questions, please reach out to me. We can set up a Google Meet, send me a screenshot of a question. And again, I'm going to be hosting Google Meets every Thursday at 1 o'clock. All right. Good luck, guys.